Okay, I think yes, we are live, and here we are again. This time, Tom and Stefan have joined us from Kraus Hamdani. Now, K1000 ULE. What word soup nonsense is that of a name for something? How on earth did your platform come with that huge name? I've always wondered that, and it's an autonomous soaring platform. Who wants to tell me more about that?
Absolutely, Gary. So first of all, it's very nice to be on your show. I'm a big fan. So thank you for having us. So K1000 ULE is an aircraft that we developed to solve a lot of problems in the industry, right? So the name ULE stands for ultra long endurance, and that's really what we aimed at creating when we built the K1000. And really the objective was to satisfy the issues at large in the unmanned industry, especially when it comes to aircraft. And if you think about it, people that develop aircraft, specifically unmanned, develop it to solve some problems. As an example, providing communications capabilities in an area, providing sensors in an area to go observe, whether it be intelligence, surveillance, reconnaissance, or other. And if you understand the problems the customer's trying to solve, for example, providing communications in an area, or again, observation, to only do it for a very limited amount of time creates an issue for the objective of what you're trying to do. So as an example, imagine that you are in a military context and you are observing a particular developing situation. Say that there are people laying an IED on a road, and it's very important to understand what they're doing. But if you have to return home because you have a low battery, that compromises a lot of the mission, and lives can be at stake in that particular regard. So by creating a platform that has an ultra long endurance capability, or pseudo perpetual, in fact, which is the case of the K1000, you have the ability to observe, understand what is happening, understand what is developing in real time, and help mitigate that particular threat so lives can actually be saved. And that's a very, very important thing. And for us as a company, at Kraus Hamdani Aerospace, saving lives is a very, very high priority because we know we can do it, and we have, right? But it also comes with other things. So the ULE, because it has these ultra-long endurance capabilities, we also now have the capability of flying different payloads and sensors downrange, right? So we can fly things that really do create an asymmetric advantage for our warfighter when it comes to the defense application of the aircraft. And especially when it comes also to the civilian application of the aircraft, we can fly multiple sensors, which reduces costs for our customers. So instead of having to fly multiple missions at very short duration, which is very expensive, it's taxing on teams, people, personnel, pilots. It's also very expensive in terms of fuel, if that's what you're running. It's also very dangerous because, as you know, every time you launch and take off, there is risk. It's the highest portion of risk in any airplane, manned or unmanned, is the takeoff and landing components. So we mitigate all of that. But here's really, I think, where I want to take the conversation today is look at the enabling factors why the K1000 really is so successful in the industry, and about how I believe we can help the industry move forward and achieve a higher level of reliability, autonomy, and capability. Excuse me. So one of the, I think, the most important things inside the K1000 is the fact that we are equipped and enabled with an autopilot called RG-Pilot. So with that, we have an open source community, which we actively contribute to and work with to advance autonomy at large, right? And if you guys follow RG-Pilots, there's different variants of it, flavors if you want. There's rover, there's the quadcopter variant for multi-rotors, there's fixed wing plane where Tom Pitcher comes in. And all of this incredible software, which I'd like, Tom, for you to maybe elaborate a little bit more on in a few minutes, runs on possibly the leading autopilot hardware platform in the industry today called Q-Pilot. Now, Q-Pilot was a very early on decision that we that we took as a company to standardize on it, simply because, and there it is. So Tom's actually holding up the new Cube Red, which is
That's actually Cube Orange Plus.
Is that the orange?
Yellow.
The color orange plus.
I do have a cube red. Now that you mention it.
And the cube red. So this technology platform, compared to others in terms of size, weight, and power, is off the charts phenomenal. We're talking about processing happening on an STM32 platform in terms of processing power, which, as you guys know, isn't much, but it's the right thing you need for an autopilot. We have multiple IMUs, so it's redundant in terms of failure, multiple magnetometers, multiple barometers, multiple gyroscopes, and in my opinion, one of the most elegant pieces of technology on any autopilot is called the EKF. Now, in the EKF, the reason why I'm so enamored with it is it allows us to have this very high level of fault tolerance in software by fusing sensor data together and giving us an ability like no other. Think about this, Gary. So in the real world, if a competing autopilot were to have a failure on critical sensors, for example, the airspeed sensor, what happens? Well, you lose your airplane, right? With Q-Pilot specifically and an ArduPilot running on that platform, the EKF fuses sensor data together, all right, to give you synthetic data in the event of a loss. So we can literally fly the K1000, and the industry at large that uses ArduPilot, and especially Q-Pilot as a hardware platform, can survive these types of failures, right? Can survive a crashed IMU or anything like this. So it really gives you the advantage. And that's really why we picked ArduPilot and Q-Pilot to begin with when we started this business. Tom, why don't you
let me just bring in Bruce XJet's got a question here. So what's the single largest factor in obtaining extended endurance?
Well, it's not a single thing. I mean, there's no such thing as the one thing that we did to make the K1000 ULE ultra long endurance, right? We had to literally go back to the drawing board and redesign everything. I mean, if you look at the competitive landscape, a lot of our competitors use off-the-shelf technology. For example, propellers from Aeronauts. Great propellers, really a big fan. However, that is not what we need. We need something which is specifically designed for application. So we had to redesign everything, not off the shelf, basically, from the very front of the airplane to the very tail. We make our own PCBs. We have to think of mass with everything we do. The materials and the resins we use are very important for lightweight structures, but also you need this rigidity of it. Let's just go back to the prop. The twist in the prop is so specific to our application that it would probably not work in any other aircraft but the K1000. Going back to the actual motor itself, the windings, the selection of materials, going back to the electronic speed controller, how that is set up, the actual software settings on that, through to the autopilot, how that is configured. ArduPilot gives us the ability to give the K1000 the exact right parameters that we need to operate in that high enduring profile. Gary, one thing which you mentioned at the beginning of the call was the autonomous soaring component. Now, yes, that is a way which we can get endurance. However, this is fascinating. Our customer came to us about 3-4 years ago and said, that's really awesome, you can do that. But however, the places in which we operate, there are no thermals. Please fix for it. So we had to go back to the drawing board and come up with another revision of the K1000, which didn't rely on thermals to get our endurance. So a lot of engineering went into that, a lot of software, a lot of hardware, a lot of material science, and literally everything, like I say, from the nose through to the tail is bespoke to the K1000 with almost no off-the-shelf parts. However, I just want to go back to the power of the Cube because that is off the shelf. And it is my suggestion to the industry, if you want to go and change the game, if you want to go and push the needle, push the envelope, and create incredible technologies, look at the Cube. Look at what it can give you. It has, in terms of cost benefit, it's there. It's affordable for both the hobbyists and commercial industry. It has the reliability. We have thousands and thousands of hours on the K1000 in all sorts of environments from all over the world, operating in high humidity areas, the desert, high altitude, low altitude, everything you can imagine. The worst of the seasons, snow, sunshine, rain, you name it, thermals, no thermals. Q-Pilot has been reliable every single time. We've never had a failure, not once in thousands and thousands and thousands of hours. Origin Pilot
You can't
has the
be.
strength behind it.
Sorry, Stefan, I'm jumping on you there, but you can't be. Well, I've got one in a carrier board back here, so you've just got that's all you use in your aircraft. You use a standard carrier board like I've got here, and away you go.
We have the cube, but we had to for our application develop a bespoke carrier board that the cube fits onto, right? And that also gives us the ability to do other things on the particular carrier board, which are on a public setting. However, the carrier board is a great hardware platform to put the cube on and into your airplane. It gives you everything you need from CAN, PWM, all of your inputs for your and outputs for GPS, your servos, everything you need. So as an immediate starter pack, I highly suggest that if you are looking at going into the most advanced autopilots in the world, Q-pilots, get the carrier board. It has a built-in ADS-B receiver. It gives you everything you need without having to spend tens of thousands of dollars to get something equivalent from the competitive landscape.
The whole point of this design was the OEM kind of method of it, where it has the footprint on the bottom, so you mount it onto your own PCB. And like, so our aircraft, we have like, I don't think we have any PWM. It's like all CAN. So here's an example of kind of a prototype, not prototype, but like a carrier board that we have that we use for internal use. So it's here, and then it even has the socket there. It has the extra socket for when running the Cube Red. So this is.
Why don't you unpack that a little bit more for me, Tom? Well, what's the difference? What do you mean extra socket? What are you talking about?
Yeah, so on this, because our aircraft is much more of a antenna in the sky for the most part, communications are kind of a big deal for us. And so one thing that we've been kind of leading the charge on is getting native networking inside Origin Pilot. And we've been working closely with Q-Pilot on the design of the Cube Red. And on here, this has native networking built right into it. So Ethernet. You have Ethernet right off. So at 10100 base Ethernet. So what we have right here is a Cube Orange, which has serial going to another STM here that's actually doing a serial to Ethernet converter. It also can host a web page, whatever. It's running. It's an AP perif running Origin Pilot AP perif, and it's running the code, the networking stack on there. So I developed the whole system on that, and then once Cube Red becomes available, like now, we can populate this other port, unplug this, and just short a couple of jumpers, and then you get the whole thing with networking right on the board. So we have native networking. Then you don't need to have a.
But now I'm going to say. So what? What does that do for you?
That's great. It's actually fascinating that you're saying that. So the traditional industry is based on serial for communications from the ground to the autopilots. And if you think about the limitations of that, I mean, they are pretty extreme, right? Most modern radio technology, I mean, let's look at some of the good ones. You have Silvus, you have Persistent Systems, for example. Those are Ethernet-based radio communication devices. What happens is you have the ability to network over long range using those types of radios. And if you have the ability to have a ground control station that is Ethernet-based, for example, sending TCP or UDP type of data to and from your airplane, you've broken the shackles of your traditional serial type of communications, which gives you the ability to integrate natively into different payloads without having two different types of connections to the aircraft. For example, one for command and control, one for payload. You can now have a single native connection that is highly reliable and high speed, but you can also talk to the autopilots, in this case, the Cube Red from Q-Pilot. So a lot of benefits in that.
Yeah, it also allows you to have just much fuller access that's not just pure Mavlink. So you get things like you can access logs in flight. You can do things like have a whole web page on board. So without a ground station, you can still access parameters or whatever web page you want. You can on a perif version of it, I have a whole dedicated or isolated one that's a whole payload manager. So it all runs Origin Pilot running a web page. You can turn on monitor powers and of all the payloads. But even to do things like cursor on target, you can do that natively from the sky. So the aircraft itself just announces that information. You don't need to go through any translators or anything. Yeah. So you can just multiple protocols and all the usual IP things.
This
and I guess
really
when you
is.
got a... Sorry, after you, Stefan.
No, this really is the future of the way that autonomy is going to present itself in the industry. Native networking to the autopilot between the ground control station and the actual vehicle, where you have this high degree of control and capability, I think is critical. When you talk about inter-vehicle teaming, swarming, all of this is going to be moving to an Ethernet type of protocol, UDP, etc., which is lossy, which is good, which is what you want. But this opens up the industry to start creating the next generation of technologies. Serial is very limited. It's very point to point, if you want to think about it that way. While this type of Ethernet, especially with UDP, you can do UDP broadcast, multicast. That goes from one to many. It has a one-to-many relationship. This is where what QPilot has specifically done with the QBred is going to open up the industry and, like I say, change the way that things are traditionally done. So you're going to see a lot of innovation happening, specifically with QBred in the next couple of years. And that's why I really believe that what Phil's doing with the team is at the cutting edge of autonomous control or autopilot technology. And we're certainly embracing it in this way.
Well, a lot of us can remember before ground control stations, before Mission Planner, before that always, and we seem to have had a bit of a gap, shall we say, in not quite an innovation, because Mission Planner's got ever more complicated, ever more layered, and better and better and better. But it doesn't seem to have changed a great deal. But this, to me, seems like, now this is a big change. Now this is a big thing that's happening. So now your company's been working with Phil and you've been chatting back and forth and getting this done. But this work won't be just held by you and a big top secret, only Kraus Hamdani. Because it's open source, everyone benefits. Would that be a fair thing to say?
Absolutely, 100%. And we're a massive proponent of open source. I mean, if you think about it, the systems in space are based on Linux. There's a reason why. So with the open source community, we have the ability to create, develop, and again push the needle forward, right? By taking ideas from all over the world, by having the ability to really review code and understand what's going on behind the actual scenes. If you compare that to a lot of the other autopilots out there, think about this, Gary. If you work with a closed source autopilot technology, to make a modification to your autopilot, you have to engage with that company, right, on a commercial basis. And they will, for argument's sake, pick a number, charge you $100,000, whatever it is, dollars, to go make that particular change you require for your platform. Okay. You will then, within a few months of contracted work, get that updated code back, okay? Which you will then install back on your autopilot and then maybe put in about 100 hours of testing before you commit that to your production platform, right? Here's the difference with autopilots. Yeah, if that's right. I mean, that's what you would expect tier one companies to do, about 100 hours. With autopilots, specifically in the open source community, once a change is made, released in beta, you get thousands and thousands of hours being tested with that particular version of autopilot in the air from all over the world and different vehicles. And we can take all of that input, find all the bugs, get all the performance data, and make improvements, and then send that back out to the community to make the next version stable, for example. So what's happening is the community is getting the benefits of this mass adopted system, right? Where there's so many on it, figuring out what the advantage, or what the pluses are, what the minuses are, where the bugs are, and ironing them out before you put them in your platform. And guess what? There's no cost to it. The only thing which we really would like to promote in the industry here is get involved in autopilot, move over to autopilot, move over to QPilot as a stable autopilot platform that is super reliable, right? Easily obtainable, and put an autopilot on there, which is the most stable platform for autonomous vehicles in the industry, and it's going to become more and more prevalent as time goes on. For thousands of people in the community, with eyeballs on the code, testing in all sorts of all over the world all the time. There's nothing in the world that can.
No, to piggyback on what Steph was saying,
no software when it comes to
to piggyback on what Steph was saying about tier one companies, so-called, we've seen many companies, big and small, work with lots of different autopilots, and we've seen the struggles, and it's painful to watch where we just suggest, have you tried ArduPilot? And they're like, oh no, it's open source, that's cheesy. We'll get this super expensive thing, and it never performs the same way at all. Not even close. Not even close. And
then on the other side of that scale is, if a muppet like me can just put various boards into a model airplane and it works, then there's got to be some smarts in there just to you really do. From the Muppet end of it, you really have got to struggle to make it crash. So that just proves that there's some really clever stuff in there. And there is the combined knowledge, skills, and experience of the developers is quite extraordinary. But I suppose what I wanted to get back and prod you at is, surely some companies are going to be saying, but that's commercial nonsense for us. It makes no sense for my company to give away all my secrets. You're mad, man.
But that's not the IP. That's not the IP, right? You want a reliable platform.
Okay.
Why are you flying? Like, I'm sure the airplane might be yours, might have designed it, but I mean, the autopilot itself, that's not the IP. That's the enabling factor. That's your reliability right there to be able to, provide your platform to the market, to fly those sensors, to satisfy the requirement of the customer, right? You want the most reliable system to fly your payloads, and that is ArduPilot and that is QPilot, right? You want to make sure your airframe doesn't crash, because guess what? ArduPilot has got the widest capability in terms of allowing all sorts of different platforms to fly. Even if they fly terribly, ArduPilot will fly it. The Cube will be able to sense everything that airplane needs to be able to provide a reliable platform. Others not, right? So there's no secret sauce when it comes to this. This is guidance. This is autonomy. I mean, people can go and create whatever airplane they want. That is their secret sauce. How do we get our endurance? That's our secret sauce, right? But how does the aircraft get its reliability and its capability to fly? ArduPilot, QPilot. Those are our non-secret secrets. And if the world wants to go and create the best platforms, that's what they should be doing, right? Their IP is in their actual aircraft technology that they build. The airframe itself.
I've seen so many times where someone writes some code to do some special thing, and they're like, "Oh, we have some special flavor of ArduPilot. We did our own custom thing. That's great. Whatever you added, I swear it comes out in like a few months in ArduPilot way better. When you do it in isolation over here, it just never works out. Doing the community, it's always just it always ends up being better. Writing code in isolation like that just doesn't work well.
Yeah, it's the same thing about if you think about, if 2 or 3 guys get together and create something cool and they keep it to themselves, okay, versus opening that up and they have thousands of people now being able to use that and making improvements. Because guess what, Gary, you can't fly your airplane in every single condition in the world, all over the world at the same time. But if you open source it, that happens. You get that feedback. And if you want to make the best technology in the world, that is how you go about doing it. It's the collective intelligence, human intelligence that comes together to create it. It's the likes of Tom Pittenger, for example, leading the charge when it comes to RGplane, with guys like Tridge and the rest of the community coming together with their big brains and saying, let's drive this forward, open source it, and get the community's feedback to keep advancing, right? It's also part of how we as a company were able to advance so quickly. It's by adopting these core technologies. Again, ArduPilot enabled us to not just move forward, but leap forward, okay? QPilot gave us the reliability and robustness we needed to operate all over the world. And we got that, right? And that's why the K1000 has become so successful and displaced other manufacturers in the market. It's because of these core decisions at an early on basis. And this is why I'm so adamant that the industry take a serious look at both RGPilots and QPilots as a combination to go and advance what they have. And whether that be a multi-rotor, again, fixed wing, a rover, a seagoing vessel, it doesn't matter. This is the power of the collective coming together and leading the industry really at large.
Yeah, I agree. It absolutely is. Cubes are in 6 out of the 11 of the blue ticketed machines, hashtag, for instance, and nearly all of the NDAA ones. Not necessarily I agree with all that, but anyway, that's another conversation. So to round this off, then, so what am I gonna look for with network enabled autopilots and aircraft in the sky? How much difference is that going to make? Because this is really cutting edge. This isn't for everybody. It's not for me at the moment. I wouldn't know what to do with a red. It's definitely beyond my pay grade, but it will be coming my way, and that sort of technology will be part of my life. So at the lower end of things, how's that going to help me, do you think, in a couple of years' time?
I tell you what, so once a new technology rolls out like this, you are going to start getting adoption, because people are going to start realizing the power of integrating this into my greater network on the aircraft with payloads, with everything else, and autonomy and inter-vehicle communications. So you are going to see, especially with I think our generation and younger, that's very au fait and familiar with computer networking, adopt this and create new technologies and new solutions that push us into literally the future of what is to come, right? So we have, obviously, being at the very forefront and spearheading this effort together with Philip at Q-Pilot, pushing this technology gives us the advantage of showing what could be done. I mean, right now we are working, Tom is specifically working on a lot of swarming stuff, which is all IP based, right? Or Ethernet based. So this opens up a new paradigm in autonomy. This is no longer a single user to vehicle control mechanism. This is no longer a limited space like we are traditionally used to it being, Gary. This literally is a future, and we are really happy that we are at the forefront of ushering it in together with Q-Pilot.
No, it's all very exciting. And what I wanted just to add to that, what I always love about this stuff is, I know it's not quite for me yet, but it will be in a year or two's time. And in that year or two, everything will be sorted out, and there'll be wonderful things that I'll love. So you just sit back and wait. Sit back, relax. Just give the devs 6 months, and it'll be wonderful. I know it will.
And that's actually the best part is and Philip Rouse is really good about supplying the tools to the developers, where we kind of went to the Ethernet, but like you're saying, what do you do with it? Well, you're not going to know what to do until you have it, because you can't even do anything without that, right? And so a lot of these things like CAN and other protocols where it's like, oh, well, I have CAN, but why? Who cares about that? PWM works great for me. And then people started using CAN and realized, whoa, that's the future. Why would you go back?
Who uses PWM anymore?
Yeah,
I understand people still do that.
People do that.
Yeah, some people do. We don't, but some people do. So same thing with the Ethernet. It's one of those things where we've opened the door, and Tridge has done a lot of recent work adding some PPP protocol and some other things that really open up the doors really wide to allow us to do some pretty amazing things with the Ethernet. So it's going to be one of those things where it's future proofing your system, and you don't need to redesign the whole thing.
Well, that's the great thing, isn't it? Sam Tabor works with you guys, I think, and he did the autonomous code, soaring code. Did great, fantastic work on that a few years ago. And one of the things that blew me going off the top again, but blew my mind was that I added the code to the autopilot. No weight, nothing changed, and then magically my airplane went from a standard RC airplane to an airplane that could autonomously soar. And all I'd done was added an incredible weight of code. It's just you have to have an imagination. You have to have.
But Gary, this is because using RG-Pilot, it has all the abilities, right? And I think about that. Think of any other autopilots in the world, software-wise, or even hardware-wise, that can just do that. Doesn't exist, right?
No, it's true. And on that note, as we come up to 30 minutes on the nail, I think that's a perfect time for me to say thank you very much to both of you, Tom and Stefan, for your time. Dear viewer, wherever you are in the world, look after yourselves. Cheers for now. Cheers, everyone. Bye-bye.